My name's Ross and I'm the co-founder of MathJot. I've been asked to show you a couple of quick ways to use MathJot and get ahead with your first calculation, or jot as we like to call it. So when you first open the calculation page, you'll get something like this. The float-in form in front of you gives you ability to start a new copy of any calculation you've previously worked in. You've got some of the public ones, the free ones. You've got your personal jots, or premium if you're part of our paid subscription. So I'm going to do a quick column load takedown today. So I'm going to start with under estimate here. I'm going to click on column load estimate. It's going to give me a column, I think, which we will look at in a second. I'm going to hold down the control key and give a bit of space like that. And now I'm going to drag and drop on a PDF editor. Now click the edit button for that. Opens a new window, and I am going to open a tile, any PDF or image file. Now I can zoom in on this if I wanted to, or I can just click the fit to screen. So the first thing I'm going to use the calipers on the left, and I am going to click and then hold down shift so that I click, so I align to the key compass points. So I'm going to follow that column along to here. I'm going to set that to 4 because I know it's 4 meters long. So now I'm going to do it in area again. Just click each of the main node points, holding down shift so that I lock it into place. And I'm just going to press enter to complete, and I'm going to call this A_TC1, which is area of tower column 1. I'm going to reduce the line thickness to 1 so it looks a little bit nice. Make it dashed, make it fill, and choose a fairly, there we go, a sort of red color, and increase the transparency so it doesn't look too bad. Click off to, then I'm going to create a linear dim from here. Click once, hold down shift to there, and I'm going to call this one, and call this line facade underscore TC1. And you can also actually force the dimension. So if I want it to be 7 meters, I hit 7. As long as I press enter, it will do that, and it will reset the length to that. Right. If I wanted to quickly adjust this, I could use the drag handles with the shift key. There you go, with the snap line should appear. There we go. Now I'm going to click save, and it will have appeared here. Okay, so it gives us the ability to just push that up here. So what I'm going to do is got the 2 dimensions. These dimensions are now in the calculation and are live to use. So if I wanted to use this load calculation, it comes with some predefined values. Most of our pre-written calculations comes with values, so you can see how to use it, not just a formula. So area should really be A_TC1. So A_TC1, and you can see that value has been pulled through. Facade length, if I click on that and I do L_FAC_TC1, so that's 7 meters. The live load in this building, let's assume it's 1.5. Dead load will leave as 1, and the facade load of 3 kilonewtons per meter, we'll leave that the same. This calculation comes with all of the pre-calculations for factor of safety and builds up. So UDL SLS, UDL ULS, facade SLS, facade ULS, and then load per floor gives you basically the UDL times by the area plus the facade load, and you have both the SLS and ULS, and then the column stack load. These all are the load per floor multiplied by the number of floors. The number of floors are defined here. This is a simple array, square brackets, a number separated by column. You can make as many as you want in there. So if I go in and edit it, I actually prefer it the other way around, so I'm going to reverse it. So just go across, make 30, and I'm going to add a number in front. I'm going to type 40 with a comma. And so I get 4 columns now, 40 floors, 30 floors, 20 floors, and 10 floors. MathJot is written so it's an element-wise calculation. So any single number you multiply against an array, that number will be applied to each of the elements within the array individually. It's not a matrix calculation. You can set matrix within the settings, but most useful is the element-wise calculation. So now you can see here, which is the one we're most going to be using, is column ULS, which is 15 meganewtons, 11 meganewtons, 8 and 3, going down. There's also an SLS load and a minimum load, which is 90% of the dead load only, no live load included. So for example, if you were wanted to check a tie down or something like that, it's there useful. So we're going to click the button to add a new a new page. So we've got a new page there, and now what I need to do, if I go into here, I go into Premium Jots again, and I'm looking for an axial load. So if I do axial, there you go, under estimate from Australian Standards AS3600 estimate, there's estimate of column size from axial load. So if I drag and drop that onto place, and there's the small calculation. We've got the column load, the FSY, the F prime C, and the area of steel you want, which is AS underscore percentage, essentially 1%, and then the area required, which is just a reworking of the squash load. So what we're going to do is we've already got the column ULS defined, and as you can see, it's been redefined here. So what we do is we drag a box over it, select it, and delete it. And now we can use what was previously defined. MathJot has a vertical definition, so if the last time it was defined is the thing that is going to be used going forward. So you can see now that we deleted that column US, which was 20,000, it is now using what was defined above it, like a normal hand calculation, which is the whole concept. So we're going to reuse the command and button, or we could group select and move around if we wanted to, but I tend to find it's easier to drag with the control key just to bring everything up. This calculation gives you the area required. Square root will give you a square, and then it's got two others, divided by 450 and divided by 300, which obviously depends on, increases the length as the column gets thinner. If you wanted to change anything, just double click on that and you could reduce that down to 200 or 250 if you wanted, and then when you release it recalculates. So you can see that. If we wanted then to save this, just change the name, and we can go across and call this tau column TC1 column load estimate. And here, if I wanted it in a particular project example, and I can call it building 2, and then I click File, Save. Now if I wanted to print this as an to put in the project, and let's say load takedown TC1, I can add a calculation number, client, job number, all the usual sorts of things. There's also a footer if I wanted to do that. And when we go to File, I'll quickly save. It doesn't have autosave at this point. And that was a design choice rather than something we didn't implement. A number of times we overwrite calculations that we're just fiddling with, or we're playing with ideas rather than actually doing. So there is the printed calculation that you've just seen that's ready for PDFing. Remember that this PDF editor is live, so if you decided to change this, click on it, press that button, you can go in, change this area, change this facade length, Okay, as long as you click save, this will be redone and the areas will have tracked through. So AC tower core 1, see it's the same number, and the facade length has been tracked through. So you only have to adjust that, and you can create a duplicate by, you can save a copy and call it tower column 2, so on and so forth, to make an adjustment. Thank you very much for listening. We'll do a few more tutorials on different ideas, but I hope this gets you started. If you've got any questions at all, send an email to support@mathjot.com and we'll get back to you as quick as we can. Thank you very much.